For section 4.2, we are going to be multiplying matrices, and a matrix product is the product of two or more matrices. So when we multiply them together, we have what's called the matrix product. Matrices A and B can be multiplied only if the numbers of the column in A equals the number of rows in B. So the product of an M times N and M by N and N by P matrix is an M by P. So those two middle numbers have to be the same in order to be able to multiply. So for example 1, we need to tell whether each product is defined. If so, give its dimensions. So for A here, we want to take a 2 by 5 named P and a 5 by 3 named Q and multiply them together. So this one's a 2 by 5 and this one is a 5 by 3. So their inside is the same. So our answer then is going to be a 2 by 3. And then for part B, we have R, who has 4 rows and 3 columns. So a 4 by 3. And then we have S, who has 4 rows and 5 columns. And notice the rows from R and the columns from S don't match up. So therefore, we cannot multiply these. So this one cannot be done. We will write not defined. All right, then we're going to look at multiplying matrices. So I definitely suggest taking a couple of minutes and writing this down here, the algebraic version. That'll kind of help you, guide you as you're doing your problems. So basically, you're going to take the first row, so your A1 and your A2, and you're going to multiply it by your first column in the other matrix. So you're going to do A times C, and then you're going to do the second one, A2 times the D1, and that's going to be your first term of your answer there. Then for this next one on the top right of the matrix, you're going to do the top row, and you're going to multiply that by the second column. Forgot to erase that line. So top row by second column, so the first one, and then you're going to add the second ones multiplied together. And you're going to go and do this throughout the whole matrix. So then for this bottom left-hand corner one, you are going to do the bottom row by the first column. So the first ones multiplied together, added to the second ones multiplied together. And then lastly, you're going to multiply it by that second column. So first ones multiplied together, and then you add it to the second ones multiplied together. All right, so probably makes a little more sense when we're actually doing it, but that is your kind of map to try to help you walk through the problem. All right, so example 2 says find each product if possible. So we have A times B. Well, A is a 2 by 3, 2 rows, 3 columns, and B is a 3 by 2. So our middle numbers are the same, so our answer is going to be a 2 by 2. So we're going to look at the first row along with the first column here, so these. So we're going to multiply the firsts, so 0 times 5. And then we're going to do the middles, 4 times -2. And then the last would be 9 times 6. So that's 0, -8, and 54. So that would equal 46. So in our matrix, the first number is 46. Then we are going to do the first row again, but the second column. So we have the firsts, 0 and 1. Then we have to add the middles multiplied together, 4 and 7. And then we have to add 9 times 0 for the third one. So we have 0, we have a 28, and we have a 0. So that one's going to be 28. Then we move down. You have the second row by the first column. So -3 and 5 for the firsts, 3 and -2 for the middles, and 2 times 6. So that's -15, a -6, and a +12, which would equal -9. So that would be here. And then last is our bottom row by our second column. So -3 times 1, 3 times 7, and 2 times 0. So -3, 21, and 0. Add that together, we get 18. And that would be our last entry in our matrix there. All right, and then we have B times A. So I'm going to rewrite those up here at the top of the screen so that we don't have to keep sliding back. Right, so let's check out our dimensions. B is a 3 by 2, and A is a 2 by 3. So our inner numbers are the same, and we're left with a 3 and another 3. So that means our final answer is going to be a 3 by 3 matrix. So we're going to start off first row, first column. I have 5 times 0, and I have 1 times -3. And that is going to be 0 and -3. So that's going to be a -3 for our first number. And then for our next number, we're going to go and slide over to the next column. So we're going to do the first row, and then we're going to do the second column here. So that's going to be 5 times 4 and a 1 times a 3. So that's 20 plus 3. So that would be a 23. And then last, we're going to do the first row and the last column over here. So we would have 5 times 9 and 1 times 2. So that would be 45 and 2. So that would be a 47. Then we're going to move on to the second column, or second row, sorry. Second row, first column is -2 times 0 and a 7 times a -3. So that's 0 and -21. So that would leave us with -21. Then we're going to keep that middle row and move to the middle column. So we have -2 times 4 and 7 times 3. So -8 and 21 would leave us with 13. So our middle number is 13. And then last column, we have -2 times 9 plus 7 times 2. So -18 plus 14 would leave us with a -4. So I'm going to put that there. And then we're going to slide down to the last row and then first column again. So 6 times 0 and 0 times -3. So that's all going to be zeros. So that will be a 0. Middle column, we'd have 6 times 4 plus 0 times 3. So that's 24 plus 0. So that would be a 24. And then last column, 6 times 9 and 0 times 2. So that would be 54 plus 0. So that would be a 54. And then we have our 3 by 3 matrix for our product. Part C, we have to multiply A and C together. And A is a 2 by 3. And C is a 2 by 2. So as you notice, our numbers don't match up here, which is telling us that we cannot multiply these together. So the answer to this one is not defined. There's more to this section, but I am going to hold off on that since our video is so long. So we will cover the square matrix tomorrow.